Hi everyone, my name is Taha Ibiş. We will make a presentation of electrical and electronic engineering design project. Our project is S-band and X-band antenna design. Our presentation consists of these topics. Firstly, proposed concept and detailed design, design implementation, design demonstration, and design commercialization.
Hi everyone, I am Elif. You can see our team formation. Team members' names are Taha İbiş, me, Göktuğ Alkan, and Tolga Salmi. You can see the Gantt chart on which we plan the business management for our graduation project throughout the year. In our project, we made S-band and X-band antenna design. First of all, we made a simulation with the CST program. Then we transformed the design made with production into a physical product. You can see the parameters we used while designing the antenna. For example, bandwidth, gain, axial ratio, cross-dipole, reflection coefficient, radiation pattern. Accurately, defining the needs and explaining the problem is important to the progress of the project. Need identification is the process of discovering a customer's or consumer's requirements, constraints, pain points, and motivations. S-band antenna need identifications, cross-industry applications, weather radar, navigational assistance, air traffic control. X-band antenna need identifications, field of radar, medical, military, space communications. Problem statement is sensitive international relations, the decline of cooperation in the military field, overvalued accuracy.
Göktuğ. First of all, I want to talk about requirements. This consists of engineering and marketing requirements. S-band antenna has 2 to 4 GHz and X-band antenna has 8 to 12 GHz frequency band. Their polarization is left or right-hand circular polarization. Reflection coefficient values are less than minus 15 dB. Axial ratio values are also less than minus 3 dB. I would like to talk about marketing requirements briefly. Designed antennas should have low cost, should be compact, should be targeted value in terms of gain, should be consumer friendly, and antennas to be designed must high compatibility with changing system needs and environmental conditions. The data transfer rate should be high. Data transfer must be uninterrupted. Designed antennas should be mechanically durable. Then, design implementation part. In the design implementation section, I would like to talk about level 0, 1, and 2 design. From level 0 to level 2, our design becomes more complex. Commonly, we see RF signal and beat structure at the input side and the radiation pattern at the output side.
We designed the antennas in the CST simulation program in our project. The dimensions of the antenna are shown on the slide. The type of antenna we designed is cross dipole. The first dipole antenna is L1 and L3. The second dipole antenna is L2 and L4. The 3D design of our antenna on the CST is shown on the slide. The S-band and X-band consist of one dipole structure, one reflector, and one coaxial cable fed structure. When we look at the simulation result, the desired frequency range and bandwidth were obtained for two antennas. S-band antenna performed between 1.8 and 2.5 frequencies, and X-band antenna performed between 7.2 and 9 frequencies. The far field of antennas are shown on the slide. S-band antenna has 4.2 dBi gain, and X-band antenna has 7.8 dBi gain. I can say antennas are directional antennas because gain shows us directivity. The radiation pattern of antennas are shown on the slide. The axial ratio of antennas are shown on the slide. When we look at our operating frequency range for S-band between 2 and 2.3, for X-band 8 and 8.4, we can see that it is below 3 dB. So we can say antennas are circular polarized.
My name is Tolga. I will explain the information about the design demonstration part of our projects. In this section on tests, our first test is the unit test. Here we measure the dimension values of the parameters of our antenna and the impedance of the coaxial cable. We do all this through the CST simulation program. Our second test is the function test. In this test, we check in the simulation program whether the antenna we are asked to produce meets the engineering requirements via CST. As you can see in the images, the S11 parameter, the far field and gain, the radiation path, and the axial ratio graphs provided the requirements requested from us. We also successfully passed this test. The name of our third test is the integration test. Unlike other tests here, our measurements take place in real life, not in a simulation program. We have physically measured the parameters we measured in the function test this time. We measured the S parameter and frequency bandwidth with vector network analyzer. Since an anechoic chamber is required for other measurements, we could not perform them. Here you can see the engineering requirements of high-quality S-band and X-band antennas requested from us. In this section, you are seeing the performance of the antennas we produce. We can say that we provide most requirements other than half-power bandwidth.
In the design commercialization part, I would like to talk about cost analysis first. Now, in total, we spent approximately 3,600 Turkish liras, which includes taxes and other expenses. Now, in addition, I want to talk about something economical, since I mentioned before for the marketing part. Then, when we go to economical part, it has been agreed that the budget is not unlimited, but if the budget is exceeded, it will be agreed with the sponsor in the supply of necessary materials and necessary production machines to produce the product. Thank you.
And you can see standards and certification we use antenna design in the project. For example, the first standard is electrical standards for radios and antennas. The second standard is environmental standards for radios and the antennas. Safety and health. The system will not expose humans to unhealthy levels of electromagnetic radiation and will meet conditions for safe operation identified in ANSI STDC 95.1. We use two cross-dipole antenna structures in our design. By using the cross-dipole antenna structure, we obtain circular polarization and a wide frequency bandwidth. We place the dipole antennas perpendicular to each other. With the antenna we designed, we have obtained the desired operating frequency range as per matter, radiation pattern, gain, and the axial ratio.